Awesome. So my name is Kinshuk Pahare. I'm a principal product manager in AWS Glue. And with me is Nitin Bahadur, who is the engineering leader responsible for platforms. So customers execute hundreds of millions of jobs by using the engines that we offer on Glue. So we offer two specific engines. Until now, we only offered two engines. One was Spark for distributed processing, and second was Python Shell for single node processing. And on Monday, we announced a third engine, which is based off of Ray.io. And this talk, we are going to talk more about how is that engine going to be added to Glue, what you can do with that, and how does it all sort of work together. This is the high-level agenda. We're going to talk about what is Glue. We'll understand the mechanics of Glue. So this would be one of the first talk where we actually dive deep into what happens when you actually author a job and submit this, or what happens when you actually launch an interactive session. So we'll go dive deep inside the mechanics and inside the platform. So at a very high level, AWS Glue is a serverless data integration service. Customers use this to discover, prepare, and analyze their data. They use it to ingest data from a broad variety of data sources. And they use Glue primarily to create data lake or insert data into data warehouses. What I like to basically say about Glue is that it's a batteries included service. So you have a full catalog. You have a crawler service. We're not going to talk about this in this talk. And we also ship with connectors. So if you are connecting from SaaS data sources like Salesforce, you can use these connectors, you can use the engines to ingest data into data lake or data warehouse. And obviously, we support both patterns, extract, ETL, and ELT. And again, depending on the use cases, you can use Glue for either of the frameworks. Now, one of the key challenges that customers are experiencing is that as part of data democratization, you cannot achieve democratization unless and until you have a broad variety of your user base using the tools that they are most comfortable with to get insight from the data. That's the primary requirement for any data strategy that you are contemplating. Now, to achieve that, we actually deliver interface for virtually every persona. We have the visual DAG interface for users who are comfortable writing a no-code job. We have the Glue Studio Notebook for developers who actually want a fast start time, a built-in notebook experience where they can just start authoring jobs using the programming language of their choice. We have the Data Brew interface. It's a data wrangling interface. It's an Excel-like interface for line of business users who are more comfortable looking at the columns, dropping columns, doing transforms, and performing a lot of data processing action. And then we obviously have the API SDK for the developers that want to connect their favorite IDE of choice with the Glue. Here, specifically, we support Visual Studio, obviously PyCharms, Notebook. And then last year, actually 6 months ago, we announced integration with SageMaker Notebook, SageMaker Studio Notebook. And the interesting part, and this is where, when I was sort of in the programming world, the common construct was that, hey, if you're using visual, your performance will be different. Assembly is faster than C, and C is faster than C++. But in this case, what we have done is that regardless of the interface that you are using, regardless of the personas, your job actually gets executed in a similar manner. So what we do is, whatever interface you are using, we convert that into the code that gets executed in a serverless environment. Now we are going to talk about primitives. And we offer two primitives. These are open primitives in the sense that all the APIs are public. You can author your job in whatever interface you want and use any of these primitives. So we'll dive into the primitives first. So let's start with the first one, which is the AWS Glue Jobs. This is the oldest primitive. This is something which we launched when we launched the service itself. I like to call it fire and forget system. This is where you give us, whether through Visual DAG, through code, through SQL, whatever is the interface of choice, and you give us the orchestration. You basically say, you know what, I want this job to run every hour, on a schedule, through event, and you tell us the SLA, that, hey, this is a very, very urgent job, or this job is flex job. I don't care if you execute in next 1 hour or next 4 hours, but I want this job to get executed. Depending on the SLA, your cost is lower. So if you use the flex SLA, you pay about 34% less. And you basically submit this in the form of a job, and it goes to the execution engine. And then execution engine basically takes care of the execution. Now here's an example of a job. So on the left-hand side, you see a DAG. This is where it's using a variety of sources. It has multiple S3 location. It has a database. And then you see there are a bunch of transforms and actions that are performed. And all of this thing is configured using the visual interface. And once you have configured this DAG, we actually convert this into Spark code. Now, here also, if you prefer, and a lot of customers and developers, they prefer using the visual DAG to bootstrap their project for any project where it requires a standard set of transform. You do a drag and drop, create the bytecode, and then we take care of the execution part. This is a new primitive. This is something which we launched 6 months ago during SFO Summit. We call it Glue Interactive Sessions. The idea here is that as a developer, or actually as a even visual user, the probability of success for your job goes high if you can evaluate that job in real time. What I mean by that is that if you have defined a transform, suppose a group by transform, it is better if you know that this group by transform is not going to lead to an out-of-memory error when you run this in production. So the advantage of the interactive primitive is that you can actually test this code in an interactive manner and run it in a production environment and get the result for every single line of code. And I'll explain how this works. But you can connect your favorite notebook. You can connect third-party tools like Fishon Analytics DBT, write in SQL, and get the results in an interactive manner. So how does it work? I call it coffee with the data. Actually, this is a phrase which I borrowed from a senior PE, Anthony Virtuoso. He said that interactive primitive, the reason we are building this is actually like coffee with the data. So what you do is you basically install Glue kernel on your favorite IDE notebook of your choice, or you use the SageMaker Studio notebook or Glue Studio notebook, or Data Brew, data wrangling interface, or the DBT. You specify the max number of workers. The idea behind max number of workers is very simple. You want to make sure that you don't have cost overrun. So you basically say, you know what, don't exceed more than 5 workers in this case. And you also define idle timeout. Now, this is one of the common problems that we saw last year, is that sometimes developers forget to turn off their development machines, which means that after 6 days of idle machine, your cost goes very high. With the idle timeout magic, you can actually say, you know what, after 5 minutes of inactivity or idleness, shut down this 5-node cluster. This could be a 50-node cluster. This could be a 200-node cluster. But the magic is the same. You can specify the max number of workers. And then you obviously write your first line of code. So it could be a Spark context, it could be a SQL. And AWS takes care of the rest. We'll automatically spin up the nodes. We'll spin up a 5-node cluster. We'll give you a Spark context or SQL result. And we will automatically shut down the cluster after 10 minutes of idleness in this example. So we talked about personas. We talked about interface. We talked about primitives. Let's talk about the processing engine. So today we offer 2 processing engines. Actually, as of Monday, we offer 2 processing engines. One is Apache Spark for distributed processing. Now, we support latest Spark version. It comes with distributed pandas if you're interested. It automatically scale up and scale down based on the input. This is another key announcement that we made in San Francisco Summit about 6 months ago. The idea there is that because of variety of reasons, you could have data skewness. And suppose you have a 100-node cluster, and 60 nodes are done processing the data. They are just sitting idle. Glue will identify those idle nodes and shut those down. Or during beginning of the job, when you are just doing the list operation, you don't need all 100 nodes. You just need the driver node plus maybe a couple of workers. During that time, we don't sort of scale up to the 100 nodes. We just start with 2. And as your driver requests more workers, we keep adding those. And all of that is achieved with a simple checkbox on your interface. There's no extraneous configuration that you need to worry about. And then obviously we have the built-in optimization over last 5 years. We have built multiple optimization for your data processing needs, specifically around creating data lake for S3 or Redshift. We have built a bunch of connectors around the same thing. OK. The second one is a single-node Python shell engine. And it supports Python runtime environment. It's suitable for small data set. It comes with built-in libraries to access data from a broad variety of sources. And I'll talk about some recent enhancements that we have done on the Python shell engine. And then at the foundation level, there are platform capabilities. Capabilities around security, automatically patching, ensuring that your data stays within the VPC that you have defined. This is a common problem. You want to make sure that the data flow, even during the process of integration, stays within the defined VPC. Your data sources could be in a particular VPC. You can use the VPC policy configuration with Glue. You obviously don't want to share username passwords with your developers. To make sure that you don't hard-code any username passwords, we support KMS integration, where regardless of who is authoring the job or what kind of job is authored, the username password stays in single place, and you can still execute jobs, ingest data from those sources. And then last is bring your own libraries. If you have built libraries in jar, Python, wheel file, you can actually provide this as part of job creation or as part of interactive sessions, both primitives. And the runtime environment that you're using, the Spark or Python runtime environment, will take those libraries, and you can use those inside the code. OK, so summary. You have a wide variety of personas who want to use a variety of interfaces. You can use orchestration, built-in orchestration tool around scheduling. You can use blueprints to scale your workflows or scale your developers. You have obviously built-in monitoring and scheduling tools. And then we offer primitives, jobs, interactive sessions, and engines, single-node Python shell engine or multi-node Spark engine. And then we take care of the infrastructure. So if you look at, we talked about all the way from persona to the processing engine. And this is the shared responsibility model. What we have noticed is that when customers migrate to Glue, their organizational priorities, their roadmap, and their way of thinking changes. Because now you can actually make sure that your developers are focused on doing the data processing, defining the logic, writing the data integration jobs. without having to worry about infrastructure management, automatic scaling, and taking care of all the ops stuff that comes with building a data integration pipeline. As I said, we have a single node Python engine. It's serverless. It has built-in support for popular Python libraries, and it is suitable for a small data set. Recently, we have added built-in support for AWS SDK for pandas. In the past, it was called AWS Wrangler. You can do a pip install AWS Wrangler of the library, or you can use the built-in libraries that are included. Now, if you select if you sort of select the checkbox which says we want to use the built-in analytics libraries, you automatically get support for AWS services like OpenSearch, Athena. You also get all the built-in tools to access data from S3, multiple transforms that are already included as part of the Python library. Now, everyone loves Python. This is one of those things where my 11-year-old son is also learning Python. It's easy to get started. And anyone who has done malloc in C probably can relate to the ease of programming. You don't have to take care of a lot of memory management. And that the root of all this ease is this GIL, the Global Interpreter Lock, which ensures that this ease of development does not cause any problem when you are actually running this code in production. But what makes it easy also makes it difficult to scale. And there are multiple discussions. You can Google this on GIL. And it makes it difficult to scale Python beyond a single node machine. And this is a huge problem when it comes to writing distributed Python jobs. And what that leads to, right, is a challenge around processing big data workload. So if you are restricted to a single node, you have only two options. Option one, split the data, process data in chunks. The second option is manually distribute the data. So you basically define the rows from 1 to 10,000, and then 10,001 to 20,000, and so on and so forth. And you build the orchestration around that to support it. All of these leads to problem. You either have slow processing, or you are dealing with operational complexity, or a very, very brittle pipeline, where if one of the job fails or if one of the ingestion fails for any reason, you are back to square one, because you have to manage it. So at this point, I'm going to hand it over to Nitin, because my job is to define the problem as a product manager, and Nitin's job is to solve it.
Thank you, Kinshuk. At AWS, we are customer obsessed. And on Monday, we announced something that will solve this problem of scaling Python-based data integration. We announced AWS Glue for A. We announced serverless data integration using distributed Python. You can now run your distributed data integration using native Python without having to learn distributed or parallel programming. You can now do these jobs over hundreds and thousands of instances without worrying about infrastructure. And we have auto-scaling built in. So now you don't have to worry about, OK, I'm going to run this Python distributed job. Do I need 10 instances, or do I need 15? No, I think maybe the right number is 12. Don't need to worry about any of that. We'll take care of auto-scaling based on how many workers or instances are needed at any given point in time. AWS Glue is known for its fast startup time. And AWS Glue for A is going to be even more fabulous. From the time you submit your job to the time it starts is under 10 seconds. You heard it right. Not 10 minutes, not 2 minutes. It's under 10 seconds. And auto-scaling is also instantaneous. To make it easy for our customers to do data integration, we are bundling together some commonly used Python open source libraries, such as Modin, NumPy, AWS SDK for pandas, to name a few. So now you can write code in native Python, use native Python libraries, and AWS Glue will take care of the rest. Itaú is one of Glue's customers. They're a financial services company based in Brazil. And essentially, what they have told us is AWS Glue will enable them to take their Python-based workloads and run them from small data sets to our large data sets. So how many of you over here have heard of Ray with a show of hands? OK, few folks. How many of you have actually used Ray? All right, so I'll give folks a little bit of a primer on what is Ray before we talk about how AWS Glue uses Ray. Ray is an open source framework that makes it easy to scale AI and Python applications. There are two key things here. First thing is it's open source, and the second thing is scale. The problems Kinshuk mentioned earlier were related to scale, and we use Ray to solve this scaling problem. AWS and Amazon have been a contributor to open source Ray, and we will continue to do so in the years to come. Here's a quote from Robert Nishihara. Robert is the CEO of Anyscale. Anyscale is the company founded by the inventors of Ray.io. Ray.io, the technology, was started at UC Berkeley at their RISE lab. So let's talk about what does the Ray framework contain. The Ray framework essentially contains a set of libraries. At the heart of it is Ray Core. Ray Core provides the basic primitives to build and scale applications. It has three primitives: tasks, actors, and objects. Ray datasets is the standard way to load, exchange, and process data in Ray libraries and applications. And we'll talk about that in a second. There are other Ray frameworks as well, such as RayTune for distributed hyperparameter tuning, RayTrain for distributed deep learning, RLLib for reinforcement learning, and RayServe for model serving. As Kinshuk mentioned, Glue is a data integration service. So we use Ray Core and Ray datasets to provide an effective data integration solution. So this is the only slide I have which has some pseudocode. Bear with me. I'm a geek, so I couldn't resist it. Here is a simple function that I wanted to distribute, and I wanted to show you how you would do it using Ray. Essentially, you take the function and annotate it with ray.remote, and then you can call it as many times as you want. It will get distributed, and it will run on remote nodes. So with a few lines of code, we have now converted a task into a distributed task. Ray actors are nothing but stateful workers. When you instantiate a Ray actor, it spins up a worker node, and all the methods and functions on that actor essentially now will execute on that worker node. So with a few lines of code, you've taken an application, made it a distributed application that works along with Ray. Let's go a little bit deeper into how does Ray work under the hood. Ray has a head node and one or more optional worker nodes. The head node has a driver that starts your application. There's a global control service that's responsible for cluster-wide metadata, such as remote function tables, remote objects, a list of pending tasks that need to be scheduled, and so on. There's a global scheduler that takes in these incoming tasks that need to be scheduled and figures out where to schedule them. There's an autoscaler component which decides whether we need to spin up more workers because there are too many pending tasks, or we need to shut down idle workers because there are no more tasks to execute. The Ray head node also has a worker component which does task processing. Thus, the Ray head node does cluster management, coordination, and processing. The Ray worker is all about task processing. It essentially just executes tasks. It has a shared memory object store, which is used for sharing objects between tasks running on the same worker node. It also has a local scheduler, and the local scheduler decides whether to execute the task locally or on a remote node. So now that you understand the basic idea about Ray, let's go look into how we can use it with Ray datasets. Ray datasets, as I said, is the standard way to load, process, exchange data between Ray libraries and applications. Ray datasets works over a wide variety of file formats, CSV, Parquet, NumPy, to name a few. Ray datasets enables this parallel processing across data, and to make it easier to do data processing, it offers some built-in functions. It offers built-in distributed functions for sort, group by, add column, drop column, random data shuffles, and so on. One of the problems we have seen in data processing is that applications run out of memory or they run out of disk space. Ray datasets solves this problem from the get-go by adding support for spilling over to Amazon S3. So now your application just won't crash because it's out of memory or disk. Another trend that we see in data integration is that our customers are processing large number of small files. And that creates a problem with certain frameworks. With Ray, there's the concept of grouping a set of small files into a group, and you can now process a group at a time. This just enables you to process large number of small files with ease. Thus, Ray datasets provides us all the building blocks to do data integration at scale. Now let's see how do we use this with AWS Glue. AWS Glue is a serverless data integration service. AWS Glue for Ray supports all the features and products of AWS Glue. So you can essentially now take your Ray application and run it as a job, or you can use Glue Studio notebooks to interactively author your Ray code. If you prefer your own environment, you can use Glue Interactive Sessions to use your own local notebooks or visual code editors. And recently, we also added support for Git, where you can use your code and you can sync it with a Git repo so that you have versioning for your code. Thus, Glue for Ray comes fully integrated with the Glue's gamut of products and applications. Let's see how this works with our Glue Job primitive. So your job is very simple. Write your Ray application, use Glue's APIs, or go to Glue Studio and submit the job. Once you submit the job, Glue takes care of the rest. It will spin up the head node. It will spin up one or more worker nodes as desired. It will auto-scale up and down. And once the job is over, it will terminate all the infrastructure. And as I mentioned earlier, from the time you submit the job to the time when your job starts is under 10 seconds. And here's visually how you would do it. For those of you who have used Glue, in Glue Studio, we've added a new option of Ray Script Editor. When you click on Ray Script Editor, you can do two things. One is you can provide a Ray job file that you've already created, your Ray code, or you can actually go type in the Ray code in the script details. You can also add additional Python libraries. So if you want to use other additional Python libraries, you can add those, and Glue will take care of pulling them in before running your job. Then you hit save, and when you run the job, you can run it on demand instantaneously, or you can run it at a schedule. So typically, our customers would first run it on demand once or twice to make sure it's working fine, and then they would just set it on a schedule, as Kinshuk said, fire and forget. And that way, they're able to perform the same job based on new data as it keeps coming in. I talked about the fact that we auto-scale your Ray clusters on demand. Let me give you an example of auto-scaling. This example is from a data store containing Amazon reviews of different products. Hey, we are from Amazon. We should have that, right? But we did take this data from a public data set. So if you folks want, you can replicate this. What essentially we did was we wrote a Ray script that lazily loads a set of Parquet files into a Ray data set. It then aggregates the reviews and the ratings per product and per product category. Finally, it emits the result as a sorted pandas data frame. Let's see how this job did. On the x-axis, you have time in seconds. And on the y-axis, you have number of workers that are executing at any given point in time. So this job ran for about 3 minutes. And if you see clearly or more closely, at different points in the job cycle, the head node decided it needed more workers. It had more things to do. And we scaled up immediately. The vertical lines are multiple number of workers getting added. And the time difference between the lesser number of workers to higher number of workers is pretty small. Similarly, sometime in the middle of the execution, the head node decided that it had too many workers. Some of them were running idle. So it decided to shut them down. And again, the shutdown happened in a matter of a few seconds. When the job ended, we immediately shut down all the worker nodes. Fast job and worker startup and fast termination are extremely powerful because it means you no longer have to pay for the cost of infrastructure. There's no additional cost. And this enables you to build applications that you could have not thought of building earlier. For customers who want to interactively build their Ray code, we offer Glue Interactive Sessions. As Kinshuk mentioned earlier, you can use a variety of things with Glue Interactive Sessions. So if you prefer your own environment, you can use your own local notebooks, or you can use your own visual code editors, like IntelliJ and PyCharm, to name a few. All you have to do is download our open source Glue kernel and integrate with your environment. Our open source Glue kernel will connect to your AWS account, and it will automatically submit commands and jobs to the Glue backend. If you'd rather prefer an integrated environment, then you can use Glue Studio notebooks. Glue Studio notebooks are free to use. Yes, you don't have to pay a penny for them. And they come integrated with all the security controls that you're used to with AWS. So as a developer, here's what you need to do. You write your code, and then in your notebook, you say run cell. And our Glue kernel will automatically go spin up the head node. It'll talk to the Glue backend, spin up the head nodes, spin up any required worker nodes. It'll run the piece of code, and it'll send the results back. In the notebook, you can see the results. If you like the results, you can go execute the next cell. But if you feel that the data is not right, I need to drop a column. This is not the right data that I'm looking for. I need to change it. You can go modify your cell, modify your code, run the cell again. And the beauty of all of this is you're paying us only for the time when something is actually running on the back end. You're not paying for idle time. So it's extremely cost effective. Data preparation and data integration is done by both data engineers and data scientists. Data scientists have to prepare the data before they can use it for machine learning. Amazon SageMaker Studio is a popular product that our customers use for their machine learning lifecycle. And today, we have integration of AWS Glue with SageMaker Studio notebooks. So what this essentially means is you can now do data preparation in Python from your SageMaker Studio notebooks, and now you have a single unified interface for doing everything for your ML needs. Eli Lilly is one of our customers based in US. They're a big global pharmaceutical company. And essentially what they told us was AWS Glue for Ray is going to reduce their cost significantly and reduce the latency of doing data preparation. And as a result, they'll be able to build their ML models faster and get to business insights faster. To talk about how we actually use AWS Glue and Ray with SageMaker Studio, we have a short video here by Sumedha Swami. Sumedha is a product manager for Amazon SageMaker Studio Notebook. He's here with us in the audience. You can feel free to catch him after the presentation.
Hello, reInvent. I'm Sumedha Swami from the SageMaker product team. I'd like to give a brief introduction to Amazon SageMaker Studio and demonstrate how you can use AWS Glue for Ray right from SageMaker Studio notebooks. SageMaker Studio is a fully integrated development environment, IDE for ML. Our customers love that SageMaker Studio provides a single web-based visual interface where you can utilize a comprehensive set of features to address each step of the machine learning development process. You can easily explore, analyze, and prepare your data for use in machine learning visually or using code. You can then store those model features in a central repository so that they can be used across your ML applications, thus promoting reuse and eliminating rework. You can use the fully managed, elastic, and shareable Jupyter notebooks to build your machine learning workflows with code. Finally, you can train, tune, deploy, and manage your models using a comprehensive set of purpose-built tools, all available right within SageMaker Studio. Today, I'm excited to announce that SageMaker Studio notebooks now come with built-in integration with AWS Glue for Ray. Data scientists can use the serverless Ray runtime environment managed by AWS Glue to interactively process large datasets using Python and popular Python libraries right in their SageMaker Studio notebooks. Let me show you a demo.
This is the SageMaker Studio user interface. Let me first start by creating a new notebook. I choose File, New, Notebook. Using Ray from SageMaker Studio notebooks is simple. You simply choose the built-in Glue Python kernel that you see here to get started. That's it. You now have a notebook that you can use to run your Ray workloads. Let me start by configuring the Ray environment. AWS Glue for Ray provides a useful set of commands to customize your Ray environment. Let us see some example configurations. First, I'll set the session type to use Ray using the glue_Ray configuration magic. Next, I'll configure the workers in the clusters. Their instance type using the worker type magic. The minimum number of workers in the cluster using the min worker magic. And the maximum number of workers allocated when the job runs using the number of workers magic. In addition, if there are other Python modules I want included in this environment, I can specify those modules using the additional Python modules configuration. With the environment now configured, let me initialize the Ray cluster. I do that by simply calling Ray init. AWS Glue will now initialize an interactive serverless Ray session just as I configured it above. Note that I did not have to worry about provisioning and managing complex compute cluster infrastructure to initialize this session. I only configured attributes of the cluster most relevant to me, such as instance type and the number of workers. And I let Glue for Ray take care of the complexities of building and managing the clusters. There you go. My Ray session has now been created in just a few seconds. I can now run complex workloads at scale and interactively analyze and prepare data right in my Studio notebook. Let me give an example of analyzing a dataset. I'll read a single partition from the Amazon Reviews dataset, which is in the Parquet file format. Let me run some commands so I can understand this dataset. I will leverage the metadata in the Parquet file for this. I'll first check how many records are in the dataset. Looks like there are over 9 million records. Okay. Let me check the schema of the dataset. Now, let me see a sample of a record from the Ray dataset. Great. I see that we have helpful votes and total votes as two fields in the schema and in the sample data record. Perhaps it will be useful to create a new column called helpful votes ratio so I can better understand my dataset. Let me add that column to demonstrate data transformations with Ray. There you go. You can see that the new column has successfully been added to the dataset. After you're done with your work, you can stop your Ray session using the stop session command. You will only pay for the resources that you actually used. Finally, once you're satisfied with your interactive work in the notebook, you can easily move your notebook to an automated scheduled job using Studio's built-in capability. You simply select the Create Notebook Job button, select a schedule of your choice, and hit Create. That's it. SageMaker Studio will automatically take a snapshot of your notebook, run it on a schedule, and will completely manage provisioning and deprovisioning of the cloud infrastructure required to successfully and securely run that job. That was a brief demonstration of using Ray on SageMaker Studio notebooks.
With this short demo, I showed you how you can effortlessly get started and get productive with Ray on SageMaker Studio. I cannot wait to see what you'll build with it. Thank you so much.
One of the goals that we have for our customers is to be able to do distributed data processing with ease. So the customers should be able to just write their functional code, and we run it at scale in parallel. Kinshuk earlier talked about AWS SDK for pandas. This is an open source library created by AWS. It essentially enables you to connect a wide variety of data and analytical services across Amazon, such as Amazon S3, AWS Glue, Athena, Redshift, TimeStream, to name a few. And you can load, process, transform data among these various data sources. AWS SDK for Panda works off a pandas data frame. And pandas data frame has a limitation of how much data you can process on a single node. So today, we're happy to announce that AWS SDK for pandas now supports Ray and Modin. So if you build any application using AWS SDK for pandas, they will now transparently auto-scale and run in a distributed manner. Yes, you heard it right. You don't have to change any code. Your application using AWS SDK for pandas will transparently get your data processing done across hundreds of nodes. The beauty of this is that now you don't necessarily need to learn Ray. All you need to understand is, what am I trying to do as a data engineer? What is the data transformation job I'm trying to do? So use the SDK APIs, and you're done. We are bundling together AWS SDK for pandas along with our Glue offering. So whether you create a Glue job offline or whether you create it using notebooks, you can directly access and call these APIs, and they will transparently run along with your Ray job. Throughout this presentation, we've talked about how fast AWS Glue for Ray is, how fast we are able to scale up and scale down. This is all part of our strategy of making data integration instant on. Waiting for infrastructure to come up while trying to do a business activity is extremely frustrating. And keeping infrastructure up all the time is expensive. So at AWS, this has been our latest innovation. We've built a completely new data analytics platform that enables you to bring up compute for analytics in under a second. Yes, in under a second. You can scale up compute and scale down compute in under a second. Now, you start your analytical application, and infrastructure magically appears. You don't have to worry about infrastructure. Today, we are talking about AWS Glue for A. On Wednesday, we announced Amazon Athena for Apache Spark. Both these products use the same data analytics platform. We essentially built this platform and released this on AWS Graviton instances. AWS Graviton instances are cheaper than their x86 counterparts and have superior performance. Again, we have the best interests of our customers in mind. We also designed this technology to be future-proof. We designed this technology to work natively with IPv6. As a customer, you don't need to know about the IPv6 part, but using IPv6 helps with IP scaling, which is a big deal when you're working across massive workloads and thousands of instances. We believe this technology is going to open up new use cases for AWS and Amazon in the years to come. With that, I'll hand it over to Kinshuk to go over the logistics of the product launch.
Awesome. Thanks, Nitin. Now, this is the logical place where we could have concluded this presentation. But since we are the last presentation in the last day of reInvent, we said we are dealing with the passionate audience, so we have a second demo that we have prepared for you on how to use it. So before we get to the demo, I do want to talk about the worker type. So we actually, it is in preview right now. It's available in 5 regions. And as Nitin mentioned, we are using a new type of worker, which is a Graviton 2 instance, which comes with 8 virtual CPUs and 32 gig of RAM, so that you can plan your data integration workloads. OK, so this is the last demo.
Sumita has just demonstrated AWS Glue for Ray from SageMaker. Now let us open Glue Studio and take a look at some of the innovations AWS Glue brings to Ray. Ray can now be seen as a new job type in Glue Studio and can be authored via Glue Studio notebooks. When creating a new Jupyter notebook, users are now presented with a kernel choice, Spark or Ray. Choosing Ray will configure the Glue Studio notebook and its subsequent job for use with the Ray engine. We have introduced several new magics for use with Ray. Glue Ray allows me to specify Ray as my Glue execution engine. Number of workers retains its use as the maximum number of workers Glue will provide to a session or job. Min workers is a new magic that allows me to specify the minimum number of workers a Ray session or job will run with at all times. Z.2x is a new worker type for AWS Glue. Each Z.2x worker provides Ray with 8 CPUs and 64 gigabytes of memory, powered by Graviton 2. The object memory magics allow me to specify a percentage of the total node memory to dedicate either to Python or to Plasma, Ray's distributed object store. We can begin using Ray by importing Ray and running ray.init. Just as with Spark, running our first lines of code will start a session. When not installing additional modules, Ray on Glue takes an average of 4 seconds to start. Let's start off by looking at our cluster status. we can see that we have only a single instance, the head node. This head node gives us 8 CPUs and roughly 40 gigabytes of Python memory and 20 gigabytes of object store memory. Ray is designed for the cloud and is natively auto-scaling. AWS Glue on Ray enhances this auto-scaling to dramatically reduce both the scale-up time of new workers and the shutdown time of idle workers. Scale-up is a simple Python function decorated as a Ray task that will request 1 CPU per execution. We will run this task 64 times in parallel to demonstrate Glue's auto-scaling. Ray has some overhead in launching and scheduling additional nodes. Tiny tasks such as this are rarely recommended for use on Ray. We can see that Ray is allocated a total of 56 CPUs to handle the load we requested. Due to overhead, it is very likely that some of our tasks finished before Ray was ready to schedule the others, requiring fewer physical CPUs than we had thought we had requested. As shown, AWS Glue for Ray can very quickly scale up a large number of workers as tasks and actors require. The greatest advantage to a fast scale-up is the ability to minimize waste by quickly scaling down unused and unneeded workers. AWS Glue for Ray will remove idle workers just 1 minute after they are no longer required, making Glue a very cost-effective way to run Ray workloads. AWS Glue for Ray includes the AWS SDK for pandas, formerly AWS Wrangler, which has been updated to work seamlessly on Ray's distributed framework. The SDK for pandas does so by taking advantage of the Modin project to distribute pandas data frames across Ray's Plasma memory store and allows for the distributed use of standard pandas APIs. With the SDK for pandas, we can interface AWS Glue for Ray with other AWS services natively. For instance, we can create pandas data frames from S3, Redshift, and OpenSearch. We can work with the Glue data catalog. We can even read data secured by lake formation at any granularity. With Wrangler, we can explore the Amazon Reviews dataset. We can retrieve a list of directories very simply, looking at all the categories available to us in the dataset itself. Once we have a list of the prefixes, we can use AWS Wrangler to create a pandas data frame in Modin from that prefix. We can treat a Modin data frame like a normal pandas data frame. We can call it to view a preview, or we can run transforms using pandas data frame APIs. Modin automatically distributes the work across the cluster as needed. Taking the goal of understanding the correlation of reviews to star ratings in the dataset, let's drop any row without a review body, then create a column of each review's length, and view that column. Now we can group the data by product ID, and for each product ID, get the mean and median star rating along with the mean review length. This data will allow us to correlate the review lengths with their star ratings. When we are finished with our transforms, we can write the pandas data frame out to Parquet on S3 and create a new table for that data in the Glue data catalog. When our data frame finishes writing, we can use the SDK for pandas to create a new data frame from that table, verifying our work. Once we are finished, we can stop the session with Stop Sessions magic, save the notebook, and schedule the job as always.
Awesome. So now, this is the last slide. Finally, we have 3 engines. We talked about the primitives, we talked about the authoring interfaces, and then now, with the introduction of Ray, as a Python developer, you can actually distribute your Python workload. I'm going to end this on this slide. This actually talks about all the capabilities that Glue offers, from connectors to transforms to crawlers to catalog to engines. Thank you very much for your patience, and looking forward to getting feedback on the preview product.